Hello, welcome to Extreme Diag. Today, we're looking at a 2015 Ford F150 with a check engine light. The owner hasn't noticed any driving issues. The Ford F150 is the best-selling truck in North America. The truck is just the right size, making it easy to drive. It also has plenty of workspace, which makes it one of my favorite vehicles to work on. There's an older Porsche parked next to us. They parked quite tight. If I scratch it, I'll have to leave the country. I need to back out very carefully. The engine starts fine. There's the check engine light. It's actually hidden right behind the RPM gauge needle. I'll drive around a bit, and then head back to the shop. You can see the check engine light more clearly on the screen now. I didn't notice any issues while driving. Let's run a scan first. We have the results. There are two PCM error codes. We have P06E9 and P1450. P06E9 is related to the starter. The customer didn't mention any starting issues. In my experience, this code doesn't trigger the check engine light. This is kind of a generic code. If there are no clear symptoms, I usually ignore it. Let's set that aside for now. P1450. Unable to bleed up fuel tank vacuum. This is an EVAP related code. This code will trigger the check engine light. We'll diagnose this code. Before diagnosing, let me briefly explain what the EVAP system is. It may vary slightly between manufacturers. Modern cars have more complex EVAP systems. But I'll give you a basic explanation. EVAP, which stands for Evaporative Emission System, prevents volatile gases in the fuel tank from being released directly into the atmosphere. It captures these gases and sends them to the engine for combustion. This system is important for minimizing environmental pollution. The main components include the fuel tank here, these hoses, the EVAP canister here, the fuel tank pressure sensor here, the EVAP canister vent valve, and the EVAP canister purge valve. The fuel in the tank naturally evaporates somewhat. These vapors are captured and travel through these hoses to the charcoal-filled EVAP canister. The PCM controls both the purge valve and the vent valve to direct the captured vapors into the engine intake system. When diagnosing this system, it's important to note that the purge valve is normally closed and opens when 12 volts are applied. The vent valve, however, is normally open and closes when 12 volts are applied. Now, let's find out where the problem is in this system. Let me search for any TSBs. Searching for P1450. Nothing comes up. Let's look at what triggers this code. This DTC sets when the evaporative emission running loss monitor detects excessive fuel tank vacuum, with the engine running, but not at idle. To summarize, the PCM detected excessive vacuum in the fuel tank while driving. Why would the PCM think that? Let's get into the diagnosis. Modern cars have more complex EVAP diagnostics. Fortunately, this car isn't too complicated. When diagnosing EVAP systems, I usually start with the purge valve. Depending on the vehicle, this can be the quickest solution. I'll use the scan tool to force both the purge valve and vent valve close. Then start the engine and monitor the fuel tank pressure sensor data. If the purge valve is properly sealing between the engine intake and the fuel tank, the fuel tank pressure shouldn't drop. If the pressure does drop, it means the purge valve is leaking. Unfortunately, my scan tool cannot control more than one component at a time. OEM scan tools can do this. There's a simple alternative to closing the purge valve. We can disconnect the purge valve connector. This is the EVAP purge valve here. I'll disconnect the connector. And start the engine. I'll use the scan tool to close the vent valve, and then monitor the fuel tank pressure sensor data. Did you see how it dropped and then went back up? When the pressure gets too low, the scan tool overrides my command to protect the system, and reopens the vent valve. That's why we saw it drop then rise again. From this, we can immediately conclude that the purge valve is leaking. Now let's check if the rest of the system has any issues. I'll use the scan tool to close the vent valve, bypass the purge valve, and introduce physical pressure into the system to see if there are any other leaks. For this type of diagnosis, we use a tool called a smoke machine. It injects smoke or pressure, so we can either find escaping smoke or watch the gauge to detect any leaks. This is what our shop's smoke machine looks like. It's quite simple to use. Watch the gauge carefully. If I block the hose completely, with no leaks, the gauge drops all the way to the bottom. I'll connect this hose to the system, bypassing the purge valve. I'll use the scan tool to close the vent valve, and watch the gauge. It's dropping slowly. It would be best if it went all the way to the bottom, but the EVAP system does allow for some minor leakage, so as long as it gets close to the bottom, that's acceptable. It has dropped to the bottom. My conclusion is that the rest of the system is fine. I'll recommend to the customer that we replace the purge valve. My colleague handled the part replacement, so I wasn't able to capture it on video. The EVAP purge valve is very easy to replace. You can find many tutorials on YouTube. If you search for 2015 F150 purge valve replacement, several videos will come up. If you're curious about the replacement process, I recommend watching this video. Anyway, it's been over 2 weeks since the customer picked up their vehicle, and we haven't heard from them.
Nice.
No news is good news. I consider it a success when we don't hear back from a customer for more than 2 weeks.
What happened?
I won.